ideas. And this is a great concept because it uses a lot of the skills that we've been doing here in Algebra 1. They are a bit of a challenge, but we can do it. So the general process is these 5 or 6 steps rather, starting with marking our text, because obviously this is a big paragraph problem, so there's some things that we'll have to untangle in there. So I'm going to start by marking the text. A piece of land is zoned for an apartment building that will consist of a maximum of 40 apartments. So 40 units within one big building, totaling no more than 45,000 square feet. The builder is planning to construct 1-bedroom apartments that will require 1,000 square feet of space and rent for $200 per month. And 2-bedroom apartments that will take up 1,500 square feet of space and rent for $280 a month. Assuming all the apartments will be rented, how many of each type of apartment should be built to maximize rental income? What is the maximum rental income? So there is our question. So I marked the text pretty well. So identify and label the variables by answering the question you've boxed. So assuming all the apartments will be rented, how many of each type of apartment should we build? When they say each type, they mean 1-bedroom or 2-bedroom. So we can answer the question, we or they or whoever should build blank 1-bedroom apartments and blank 2-bed apartments for a max profit of blank. Once we know how many 1- and 2-bedroom apartments we need, then we can figure out the profit. I wrote blank instead of putting a blank. So it's really the number of 1- and 2-bedroom apartments that we need to know. So those will be our variables. So I'm going to say that X equals 1-bedroom apartments, or the number of 1-bedroom apartments. And Y is the number of 2-bedroom apartments. From here, identify constraints and write an inequality statement with the variables. So there are things that are holding us back from just building, a 700-unit apartment building. Like, we're zoned for only 40 apartments. That's one of our constraints, the number of apartments. Do 42 bedrooms, or we could do 41 bedrooms, or some combination of numbers that add up to 40 with the 1- and 2-bedroom units. So one limitation is when we take the number of 1 bedrooms plus the number of 2 bedrooms, it has to be less than or equal to 40. So then when we max out the 2-bedroom apartments, yeah, except for I know that there's a requirement on square footage. It can't go over 450,000 square feet. That's another limitation that we have. In every 2-bedroom apartment, let's see, 1-bedroom apartments will require 1,000 square feet. 2-bedroom apartments will take up 1,500 square feet. So every 2-bedroom apartment that I have to multiply that by 1,500 square feet. And if I do 40 of those, that would be 60,000 square feet. So that would put me over it. So I have to probably put some 1-bedroom apartments in there, or at least I can't do all 40 as 2-bedroom apartments. But 1-bedroom apartments, which is X, is the number of them. Each one of those takes up space. Each one takes up 1,000 square feet. So 1,000 times X. So those are the two constraints I see, but wait, there's other numbers in there, right? So it says that the one-bedroom apartment rent for $200. Now that's not a constraint. That's what our goal is, to get a profit here. So this is not a constraint. One of the last equations we'll write is what we're trying to, our objective, what we're actually trying to do. We're trying to make a profit. So for every every one-bedroom apartment we rent, we multiply that number of them by $200. That's what we make per month. And then for every two-bedroom apartment, we have to multiply that by 280. And that's not a constraint. That's going to equal P, our profit. Well, not necessarily the profit, but what they make for rent. In 2017, rent is usually a little bit more than that. So we've identified the constraints and written our inequality statements. We also identified the profit, or the max-min equation. So now we're going to graph just our constraints. We do not graph the profit. That'll tell us what quantities we can actually make. Now these are in standard form. Some of you like slope-intercept form better, so by all means, if you want to solve for y in each of these respective equations, do it. However, it's easy to get my x-intercept for this top equation. When y is 0, x is 40. And it's easy to get my y-intercept. When x is 0, y is 40. Remember how we said that when we add the number of apartments together, it has to add to 40? This line that I'm about to graph is going to show us the different combinations. Every point on here is a solution of ways to add up to 40 with the number of one bedrooms and number of two bedrooms. But again, we have an issue with this up here because we can't have 42 bedroom apartments because of our other constraint. So we have to graph both constraints. And by the way, if I were to shade right now, I could shade underneath this first line because we don't have to. We have to be underneath or at 40 apartments. So anything down here is less than 40 combined apartments. So we can go up to that line, then we're right at maxing out the number of apartments we can have. But again, there's this square footage restriction. So let's graph our square footage restriction. So square footage restriction is the other constraint equation right here. So if I were to find the x-intercept, so I'm kind of mentally scratching out or plugging in 0 for y, I'm going to get no two-bedroom apartments. I just want to max out one-bedroom apartments. I could get 45 of them. Yes, that's outside of our feasible region, but please graph this line. We need to graph this line accurately. So that's my x-intercept. Now let's get our y-intercept. So 1,500 times what is 45,000? That's going to be 30, I believe. So my x-intercept is 30. Now with a nice straight line, we want to connect these, and we do need this to be straight. Because in a second, we need to know exactly where that intersection is. But first, let's think about what this means. This was our square footage restriction, and we need to stay under 45 or at 45,000 square feet. And this blue line is 45,000 square foot combinations. So I've got to stay under the blue. So this is me shading underneath the blue. But then we also need to stay underneath the black. So it's really the black line. So really it's making sure that we're meeting both restrictions. We have to stay inside this region. This is what's called our feasible region. And there's so many combinations of 1 and 2 bedroom apartments. But to get our maximum, it's going to be one of the intersections, one of the vertices or corners of the polygon. Let me go back up. So we've graphed the constraints, And now we're gonna, all we need to do is test the vertices that are the corners of the feasible region. That's the overlapped region that meets all requirements. So we can either max out 2-bedroom apartments by doing 30 of them, because square footage wise it limits us down to only 30 of those. We could do 30 1-bedroom apartments and 10 2-bedroom apartments. Let me write this down. So 0, 30, that means number of 1 beds and versus number of 2 bedrooms. We could do 30 1-bedrooms and 10 2-bedrooms. Or we could max out 1-bedroom apartments. Of course, we can only do 40 of those. So now we're going to use that profit equation, that 200x plus 280y equals p. And we're going to substitute 0 in for x and 30 in for y and continue to do that. So 200 times 0, which we don't actually need to even calculate, plus 280 times 30 gives us a profit of $8,400. Not a profit, excuse me, a earning from rent of $8,400. There's expenses into owning that stuff too. And then let's do 200 times, so let's get 30 1-bedroom apartments and 10 2-bedroom apartments. And that's going to equal, I believe, even better than the other one, 8,800. And last but not least, just maxing out the 1-bedroom apartments, but getting no 2-bedroom apartments. That's $8,000. Remember, this is 1 month, so each month, this apartment might get rented out for hundreds of years. It matters that that's the biggest profit by $400, and that happens every single month. That's a lot of money. So that's if we get 31 bedrooms and 10 2-bedrooms. So we can now answer our question. We should build 30 1-bedrooms and 10 2-bedrooms, and that gives us a maximum profit of $8,800.